In this video, we're going to look at an ellipse. Starting in general form, we're going to convert to standard form, and then we're going to identify all the important characteristics of the ellipse and sketch a graph. Here I have the general form of the ellipse, and in order to start working towards standard form, I need to regroup my terms so that we can complete the square in x and also for y. So I'm going to group these two x terms together, x squared minus 2x. Save a little room to complete the square. I have this 4y squared and negative 24y. We're going to group those together, but also I'd like the coefficient on my y squared term to be 1. So I'm going to go ahead and factor out a 4, which would make this y squared minus 6y. And I'm going to save a little room to complete the square. And then we have plus 5. And now, whatever we add in here when we complete the square, we need to subtract those numbers off. So I'm going to go ahead and add minus square, and then for the y completing the square, we've got to multiply by that 4 that we factored out, and then this is going to be equal to 0. All right, so let's look at our x's. Switch a little color here. And we've got x squared minus 2x. If that minus 2x is our 2BA term, then that means that our B value is going to be negative 1. If we divide that negative 2 by 2, we get negative 1. And remember, in the box, we want that to be B squared. So negative 1 squared is 1. And then I'm also going to put that 1 over here to make sure we subtract it off. Now for the y's, if this is the 2BA term, that means that our b is going to be negative 3, and so then our b squared would be 9. And so I'm going to put that in both of those boxes. So now we're ready to complete the square. For x, this is going to be x minus 1 squared plus 4 times y minus 3 squared. And then I have plus 5 minus 1 and minus 36. And so that's going to give me minus 32 equal to 0. So now I'm going to add that 32 to the other side. And then remember, when we get this in standard form, we want the right side to be a 1. And right now it's a 32, so I'm going to divide everything by that 32. And we end up with x minus 1 squared over 32 plus the 4 over 32. That reduces to 1 over 8. So I have 1 minus 3 squared over 8 equals 1. Okay, so now we have our ellipse in standard form, and we can start working on identifying the important characteristics of this ellipse. Remember that our center comes from the square binomials, x minus 1 squared and y minus 3 squared. If we look at those, we can see that our center is going to have the coordinates 1, 3. The foci, that we're going to need to calculate our C value before we can find the foci. So let's go ahead and do the endpoints of our axes. The major axis, that of course is going to be the longer axis. And its length is going to be 2 times the square root of the 32. So that's the bigger number, the larger denominator that we have up there in our standard form. So that means that our a squared is equal to 32, and a is going to be the square root of 32, which is approximately 5.6. So the endpoints of our major axis, since our ellipse is going to be opening in the horizontal direction, this is going to be longer horizontally than vertically, then that means that the y-coordinate of the endpoints of the major axis is going to be the same as the y-coordinate of the center. It's only the x's that are going to change because this is a horizontal ellipse, and it's stretching out in the x direction. So we're going to have the center value 1 minus the square root of 32, or minus 5.6, and the y value is going to be the same. And then we're going to have 1 plus the square root of 32, or plus the 5.6, and our y coordinate, again, is still going to be 3. Now to find the endpoints of the minor axis, we're going to use the 8, the denominator under the y binomial. So that's going to be our b squared is 8, which means that b is going to be the square root of 8, which is approximately 2.8. And so then to find the endpoints of our minor axis, this is where I'm going to go up and down in the y direction, and that means that my x coordinates are going to stay 1. It's just the y coordinates that are going to change this time. So we're going to go 3 plus the square root of 8, or 3 plus 2.8, and 3 minus the square root of 8, or 3 minus 2.8. So we have our center, the endpoints of our axes. We need to find the focus. Now, in order to find the focus, we need that c value. And remember, we're going to use a Pythagorean relationship, but we're going to think about which number out of a, b, and c is going to be the biggest. In an ellipse, it's the a that is the biggest. And so that means for this situation, a squared is going to be equal to b squared plus c squared. Now a squared is 32 and b squared is 8. I got both of those from our standard form, and then plus c squared. C is what we don't know, that's what we're looking for. So c squared equals 24, which means c is the square root of 24, which is approximately 4.9. We'll use that to help us graph. But that means to find our foci, again, the foci, they're going to be along the major axis, which means that the x's are the only thing that's going to change. My y coordinates are going to stay the same. So for the first focus, we're going to do 1 minus the square root of 24. That y coordinate of 3 is the same. And then the second focus, 1 plus the square root of 24. Again, that y coordinate of 3 is the same. So now we're ready to sketch a graph of our ellipse. I'm going to start with the center, which we identified previously to have the coordinates 1, 3. So that's going to be about right there, 1, 3. And then to get to the endpoints of our major axis, we're going to go square root of 32 in each direction. Square root of 32 is about 5.6. So 1, 2, 3, 4, 5. 5.6, maybe about here. And then in the other direction, about 5.6 right here. To get the endpoints of our minor axis, we're going to go up and down the square root of 8, which is approximately 2.8. So I'm going to put a point about here and here. And our ellipse would look something like this. The foci, if we want to go ahead and graph those on our ellipse, remember that they're going to be plus or minus 24 from the center, which is approximately 4.9. So maybe about here for focus 1, and about here for focus number 2. One thing that I forgot to calculate before was the eccentricity. Remember that to calculate the eccentricity of ellipse, or of any of our conics, it's equal to c over a. And so for this particular ellipse, it is the square root of 24 over the square root of 32. And I see that I could rewrite this as square root of 8 times square root of 3 over the square root of 8 times the square root of 4. And of course, those square roots of 8 would divide out and become 1. And so I'm left with the square root of 3 over square root of 4 would be 2. So our eccentricity, square root of 3 over 2.